Welcome to Global Information Security Society for Professionals of Pakistan.
Good start. So, Assalamu alaikum everyone. So today is our third session. In domain 3, we have already covered domain 1 and domain 2. And if anyone wants to, go back and review those domains, all of those videos are available on YouTube, on Gispp YouTube channel. Let me see recording. Okay. So you can start it. You can go back, review those sessions before you come to session 3. One thing that I do want to emphasize, in all these domains, you will see information that is being repeated from previous domains. So, and then there is some new information in the newer chapters. And you're going to see in this domain as well that there will be some topics that we have already studied in domain 1 and domain 2. But, every domain builds upon the previous domain. So it is good that you have a connection of those concepts in each and every domain, and you revise some older or previous concepts, and then also learn about new concepts in the in CCSP. So today's domain is all about cloud platform and infrastructure security. So we're going to be learning about what cloud platform is, how it is formulated, what are the components of various aspects in cloud platform, and what is infrastructure security when it comes to cloud platform. I know we are all familiar with regular data center security, right? We talk about physical security, we talk about how data centers should be secure, how logical security needs to be in place, servers, racks, their security, everything, right? If you think about cloud, to us, cloud is very software based, right? We can log into AWS management interface, we can log into Azure management interface, and then we can, set up our virtual machines, we can set up software defined networks, we can manage our environment. Everything is API based. Everything is happening at the application layer, right, in the cloud. Because whoever has worked on the cloud knows, you open up a browser, you log in and you do your work. But at the back end, right, everything is physical, right? AWS has data centers, Azure has data centers, and those data centers have the same thing as we have data centers in our own organizations, right? So when we talk about cloud security, cloud, what we call is the specific word that we use is called abstraction. Abstraction का उर्दू में मतलब है कि किसी चीज से अखज़ करना, किसी चीज से निकालना. So what cloud is doing in a nutshell is it has abstracted a layer of management layer of everything that is physical underneath it. So you can configure virtual machines, you can configure, software-defined networks, which are actually virtual networks. You can set up security, access control, authorization, identification, everything. It gives you an abstracted layer, and you do not have to worry about the physical security. So that's a basic premise of this, domain. And we're gonna go and look at how a cloud is formulated, what are the various components when we talk about cloud platform, and how CSPs, which are cloud service providers, do infrastructure security. And when you are going to a CSP or cloud service provider to get cloud services, what type of things you need to consider when you are thinking of using a cloud service, right? So that depends upon your own requirements, your regulatory requirements, or your organization's own security requirements. So that's in a nutshell we're going to talk about today. So another thing is that if you guys have any questions, I have chat window open, and you can send me questions, and we can And I'll pick and choose questions and answer those. All right. So, all right. So now let's start with comprehending cloud infrastructure components. And everybody can see my screen? I'm sharing my screen. So if you can just type a yes over there or say it over here. Okay, good. All right, so comprehending cloud infrastructure components. So as I mentioned that in this domain, we're going to be talking about what cloud actually is and what are the various components of the cloud and how cloud infrastructure builds upon a physical environment. And physical environments, I mean servers, storage, memory, physical networking, and how everything is virtualized and connected to a management plane for you to work on it. So as you can see in this slide, you can see the cloud infrastructure is made up of multiple components, right? And each component is critical and it is playing its important role. So if you look at this diagram, starting from the bottom, you can see the physical environment, and that is the data center that I was talking about. AWS has a data center, Azure has a data center, Google has a data center. So those are the physical environments set up by these service providers. So once they have set up these physical environments, and these are huge environments, right? Generally, organizations that we work in, they might have a 1 data center, 2 data center in US, or maybe internationally. But since these are huge, huge organizations, they have physical environments set up pretty much all across the globe. And they use, very high-end technologies to connect those data centers together to provide high availability. So one of the critical features of cloud security or cloud service is high availability. And the way they provide high availability is it has to first start at the physical environment. The redundancy is important. If a cloud customer is in US, then data centers across needs to be established in multiple states and multiple zones across the US. So if for one reason or another one zone is not available, clients can access data from other locations. And in order to do that, in order to provide that high availability, we need to make sure first connectivity is there. Second, the data is replicated all across. So if one site or if one zone is down, clients still may be able to access data from another location. So that's basically what the physical environment is. Now, moving up from physical environment is virtualization. And that's where, actual cloud is starting to formulate, right? So virtualization, as we all know, we all have used hypervisors like VirtualBox or VMware or any other open source hypervisors that are out there. We are all familiar with that in IT. We have installed, those hypervisors on our, own computers, on your own laptops, and we have seen those hypervisors in our organizations. They are generally called VDIs, right? Or in US these days, this is a very common practice in organizations that organization is moving towards is that they are not giving out physical laptops or physical machines to their employees. Rather, employees can use their own physical desktops at home or their laptops that they're carrying with them. And then they connect to organizations network in the cloud and spin up a virtual machine, which is configured for them to work on for their organization. So that's how they don't have to worry about lost hardware. They don't have to worry about, patching, because everything is managed in the cloud and it is in full control of the organization IT department itself. So that's why virtualization technology is key to cloud. So, and virtualization is built upon your physical environment. So yes, so Windows 7 and Windows 10, they have built-in hypervisors, and that's basically if you are going into Azure environment. So Azure provide those, but if you're going to AWS, they use a different hypervisor technology. So it depends upon who is your CSP. Then on top of virtualization capabilities, we have compute, network, and storage. Now, think of cloud as a big computer, right? So if you look at your own personal desktop, your own personal laptop, what are the components that make up that system? It is storage, which is your hard disk, right? Which could be your RAM. So RAM is random access memory, and then you have physical storage, which is your hard disk. So that's storage. And then in your own computer, you have networking, whether it be wireless networking capabilities or wired network capabilities, right? That is part of the computer. And then you have compute. Compute is your processor, all right? So now if you take that computer and blow it up, and then you have all of these individual components have their own entity in the cloud. Like AWS storage is called S3 buckets, right? Azure has its own name. So that's the storage. So that is your storage part of the computer. Networking, AWS is their own networking service. So these whole individual components become a big, huge service, an individual service in the cloud. And then you have, compute service in the cloud. So you can see that, a small computer, just blow it up, make it on a large scale, and each component becomes its own service. And that's what cloud is. So cloud is a big, giant computer itself. Make sense? Now, we start with physical, and then we talked about, virtualization. And then on top of that, what are the different services on that virtualization capability. And then now you have all those components. Now you have to tie all those components together so that you can make it all work, right? To make it work, you have to have a management plan. And that's where we previously talked about, APIs. We talked about web interfaces. So the APIs connect the management plane to these individual services, right? And then the management plane is the web interface that people like us who are customers of a cloud, we connect to it and we do whatever we need to do. We can set up security through that management plane. We can spin up virtual machines. We can configure storage. We can configure networking. We can configure computing requirements. So everything is done through that management plane. Azure admin portal, AWS admin portal, Google admin portal, those are called management planes. Make sense? And that's how you can see all of this is tied together. So from physical environment to management plane, it's what a cloud in a nutshell is. All right, so let's, yes, go ahead.
One question about orchestrator. Does it also fall into this management layer? Orchestration?
Yes, so orchestration is part of the management plane. Orchestration is just basically automating the whole process, right? So if you want to set up, if you're a developer, in an organization, you want to set up a machine in the organization for testing. So you use orchestration like Kubernetes or other orchestration services. You use them and you spin up the environment. So yes, you are basically in those orchestration services reside in the management plane. It's just that orchestration make it automated rather than somebody logging in and provisioning those services. So it's an automated way of provisioning these services. So yes, it is part of management plane. All right, so that was the summary of how cloud works. So let's talk about physical environment. So we all are familiar with, we have studied in our, education and, in an IT environment, we have dealt with whoever work in SOC NOC environment or whoever work in data center environments. They know that what are the critical aspects when we are setting up a physical environment. And those are the same aspects that a cloud service provider needs to consider. And I would say that not only those, but even more than that, because their client base is huge. Their client requirements are varied. They have regulatory requirements, they have geographical requirements. So there are a lot of things that they need to configure, high availability requirements. So in general, when a cloud service provider is setting up their data centers, they need to understand these physical environments. And you as a customer and you as a cloud architecture in your organization, again, this certification is not a technical certification. This certification is for a person who takes up a role of a cloud architecture or cloud architect role in our organization, a person who understands how cloud works in general, and he is helping an organization for their transition or maintaining their cloud environment. So cloud architect actually deals with the technical folks in an organization. So a cloud architect may be dealing with a person who is AWS certified. So AWS multiple certifications, right? So, but with this certification, being a cloud architect, you understand the working of that cloud. You are not, specifically understanding how AWS works, what are its different services called, how technically policies are set up. You're not working on that. Same with Azure. What you're looking at, what you are learning over here is that how cloud is actually working, so that when you're working with cloud service providers, when you're working with your organizations, with your technical people in your organization, you know what to look at. You know how to write a contract with the cloud service provider. You know how to provide direction to your technical team. So that's the purpose of this certification, right? So physical environment is, you have to have physical access authorization controls. You need to understand how the data is being transferred or how data is being transmitted between your client and servers, right? That would be, network cables, preventing damages, tampering and theft. Then physical access monitoring. So if cloud service provider has those controls in place, when you go in, cloud service provider, make sure, basic control, whoever is going into the data center is signing, a logbook, right? Incident, how physical security incidents are being monitored, cameras are installed or not, fencing is there or not, who is allowed to log in. So those are the basic controls, physical controls that needs to be in place. Emergency power, fire and water damage prevention, asset monitoring and tracking. Uske baad, data center location, sufficient reduction in power cooling, sufficient and redundant network bandwidth. So these are all various factors that when you are, trying to get a service provider, you can ask these questions to the service provider. Remember in the previous domains, we talked about different types of cloud, private cloud, public cloud, community cloud. So if you are trying to get a private cloud, or if you're trying to get a community cloud service because of a specific requirement, maybe it's a regulatory requirement or whatnot, you need to make sure that you ask these questions to your cloud service provider to make sure that whatever your requirements are, your cloud service provider is able to meet your regulatory or organizational requirements. So do not assume that, okay, a cloud service provider is big, they must be doing all these things. No, you have to ask these questions. You need to understand that what are the regulatory requirements are for why you are going to cloud, or security requirements, and then map that to what cloud service provider is offering. That way you can make a educated decision to which cloud service provider you are going to select. Okay. Next. Next is, again, it falls under physical, connectivity. So network and communication. So you need to understand how your cloud service provider is routing the network between cloud on the network and between external and internal networks. Filtering, and that's basically, firewalls, if your firewall is in place or not. I mean, I have seen in many places that when a lot of organizations doing the lift and shift, by lift and shift, I mean, they have existing applications that are running on their data centers, but now since they are moving to cloud, they are moving those applications into the cloud, right? So yes, they have network firewalls, sure, that's a very basic control these days and everybody does have it, but you need to make sure that your policy meets your organization firewalling policy. The second aspect that people are missing these days a lot in terms of filtering is they do not put WAF, which is web application firewalls. So they miss those. And during that lift and shift process, people generally do not consider VAF, that it also needs to be moved, it also needs to be set up, and people are forgetting that. They are overseeing that process. So you need to consider all those things. Rate limiting, you need to, again, how much traffic you want to allow into the cloud. And you know that the cloud is all API based. Any communication that is happening between a client and your cloud environment is through APIs. So, and you can implement the rate limiting on APIs. So that one thing. Second thing is, this rate limiting concept is very important when you are talking about limiting. So limiting, we're going to talk about limiting concept in the later slide, and that is very important from the examination point of view. You will get questions about what is sharing of resources, what is limiting of resources, how you perform limiting of resources, what are the factors you consider when you are limiting cloud resources. So network bandwidth is one of the resources, right? How you want to limit that resource, because everything, every service that you're using in cloud, it has a cost associated with it. It's not free. Every bit of data, every storage, you have to pay for it. So if you are not providing limiting, then it's going to impact on your budget, right? Address allocation. Sure, go ahead.
I have one question about filtering.
Sure.
When it comes to filtering, I mean, like firewall or web you are talking about, so it's all virtual, right?
Yeah,
I mean,
it is virtual.
Yeah, right. All firewalls are like virtual, right? Web is virtual, yep, and the firewall is virtual, not like one physical.
Nope.
Not like one physical.
Nope.
Okay.
Nope.
Yeah.
It's all virtual, and it is. That's why cloud is all virtualization, and that's why we're going to talk about one thing called software-defined networks, SDNs. So, like in physical data centers, you have to actually log into the router or a switch or any other telecommunication network device and configure that, right? Cloud takes all that away and make it much more easier in the management plan. So we'll talk about that. So address location. So the process of assigning one or multiple IP addresses to cloud resources, which can be done either statically or dynamically. And you can see, the resemblance or the similarity of how you do, you assign IP address to physical servers, networking devices, computers, and any host. So the definition of host is anything that has an IP address as a host, right? So you do that in your physical world. You're doing same thing in the cloud, but it's virtual. Okay, next one is bandwidth allocation. So the process of sharing network resources fairly between users that share the cloud network. So, we talked about multi-tenant environment. So generally in cloud environment, one physical resource is being shared by many customers through the process of virtualization. Just keep that in mind. One physical resource divided into multiple chunks, which is being used by multiple customers. And that's what multi-tenancy is, that on one physical server, there are multiple customers living on that one. They are tenants of that physical environment. And how that is being done, it's being done through virtualization. Again, consider you have an apartment building, one physical building, but in one physical building, you have multiple apartments, and in those apartments, you have tenants that are living. So one physical building is providing multi-tenancy versus if you just rent a house, one single house. So one physical building is housing only one person or one family, right? So that's the same concept in cloud. So one physical environment is one physical building, and all those apartments are different virtual machines, and those virtual machines are being used by multiple customers. Make sense? Okay. So I cannot recommend any VAF. I have not worked with VAF, so you can do your own research, but pretty much all of them are pretty good out there these days. Software-defined networks. So we talked about a little bit virtualization, and software-defined network is virtualization of networking services. So everything in cloud is a service. Again, if you look at this diagram over here, you have infrastructure layer, which is akin to have a physical layer. So this is basically a physical layer. So physical layer, you have routers, switches, and whatnot. So that is infrastructure layer, your network devices, all there. And these are usually managed by employees of cloud service provider. You do not have access to these physical devices as a cloud customer. These are managed by, and then on top of that, they establish a control layer, which is the SDN controller, which basically combines all the configuration from all these devices into one layer, which is the control layer. And on top of that control layer is the data layer, which is at the application level. And that application level is the management plane that we already talked about. So data layer is the part of the management plane. So now when you log in to a cloud management interface, maybe whatever the case may be, you actually set up the multiple virtual machines, and then it will allow you to set up assign IP addresses to those virtual machines. Then it also allows you to set up VPNs. It also allows you to set up VLANs. It also provides you capabilities of securing that network, IP filtering on that network. So everything is happening at the management plane, and everything is connected to the control layer via API. And then infrastructure layer is all managed through that. So it's SDN is an approach to network management that enables a network to be centrally controlled and provided consistent and holistic management across various applications and technologies. So an SDN architecture allows dynamic and efficient network configuration, right? So you do not have to learn Cisco, you do not have to learn Rotel or Palo Alto. You do not have to worry about what technology is being used under it. You become technology agnostic at that point, hardware agnostic at that point. All you have a standardized interface in the management plane, and everybody is using that standardized interface to configure network, a software-defined network. And to connect all these virtual machines, all these, the SDN software, SDN is the key to connect everything together when it comes to networking. Any questions? Okay, let's move on. Hold on. Sorry, मेरा computer एकदम से something happened. Let me.
So we can say Rehan bhai, like Cisco Meraki, as I know, FortiGate also using the same SD-WAN concepts. They have their devices which we can manage through their portal and appliances. So it's the same thing. But
yes, exactly. So I mean, they create a management plane on top of underlying, architecture. But that's very organization specific. This is basically no matter what technology is, Meraki or Cisco or whoever it is. Can anybody see my screen now?
Yes.
Yeah.
Okay. So everybody is using a standard interface. It doesn't matter, because as a cloud customer, I don't have to deal with specific technology. I want something standard, right? So I want something standard. I want something ready for me to work on. I want something that I can set up fairly quickly, right? All that work that I used to do on Palo Alto or Cisco, it's not my headache anymore. That's the responsibility of cloud service provider. Their employees, their team is going to manage that. All I'm care is the abstracted layer of that. And that abstracted layer is accessible through management interface, and it is standard for everyone. So it makes things life very easy. Okay. So the next is compute. And we talked about in our personal computer, compute is what processor does for us. CPU, what does for us. So as the term cloud computing suggests, compute power is a big deal for cloud consumers, right? Compute resources take data, process it, and show you the output of that processes. And that's what CPU does in our computer, right? It takes the input, it processes that input, and gives us an output. So that's how a compute is similar to in cloud. And Amazon and Azure call their compute services different names. I do not know what those are, but you can go to their website and search what is a compute service in Amazon or what is a compute service. And most of the times, companies who are doing AI work, data analysis work, data science work, they are the one who actually rent these compute services. If you are doing encryption, right, so then you need powerful compute services. And the beauty of cloud is that it's not one computer that is doing all the computation work for you. The workload is distributed. There are a large number of computers that through management plane, you can connect their physical CPU and create one virtual compute service on top of multiple thousands and thousands of CPUs at one place. So for you, it may be one CPU, but through the magic of virtualization, there are multiple physical CPUs that are they're combined together to create one compute service for you. So these, with machine learning and artificial intelligence that we hear a lot these days, data sciences, compute service is very important. And a lot of these organizations which have data processing activities, they use compute services. So what's unique in cloud environment is, however, these compute resources may be managed and allocated among multiple customers. So before tackling that challenge, you should be familiar with some common types of cloud compute assets, specifically virtual machines and assets. Again, cloud is all virtualization. And in addition to that, someone I think asked a question about orchestration, and usually orchestration is used specifically in development environments to set up containers. So we will see what is the difference between a virtual machine and container, because people generally do not understand how containers are different from virtual machines. There's we'll talk about that as we go along. So anybody heard about containers before, or who are not familiar with containers? Okay.
Yes, I did. I know the
Okay.
basic difference, I think.
Okay.
Yeah.
Okay.
Yeah.
We'll talk about it. So the question is, what type of questions come from compute? There will be questions on, so since virtualization and container are part of compute function, so you will not get specific compute questions, but you will get a lot of questions on virtualization and how it works and what are the security around virtualization. And we're going to talk about that in later slides. Okay. All right, so the next one is virtual machine and containers. So we know that virtual machines are, these are files, right, on your computer. You install a hypervisor, that would be VirtualBox or VMware. So those are hypervisors that allows you to create or run virtual machines in the physical environment. So virtual machines have two major components. One is your host computer, that is your actual physical machine, your laptop or desktop. So that is a host computer. So you need to understand these terminologies. So what is a host computer and what is a guest computer and what is a hypervisor? So you need to understand, because a lot of people get confused between guest OS and host OS and what is a hypervisor. So it is absolutely critical for the exam that you know what these are and what each of them does when it comes to computing, right? So virtual machines are most common compute mechanism in cloud environment. So what VM does is it emulates the functionality of physical hardware and allow cloud customers to run OS in virtualized environment. So you have a computer, a Windows 10 machine, you install VirtualBox. So in this case, your Windows machine becomes a host OS because वो आपके it is hosting something, you know, वो मेहमान नवाजी जा रही है, और उसके बाद you have, you know, virtual hypervisor. Think of hypervisor as your drawing room, जहाँ पे आप अपने मेहमानों को ला के बिठाते हैं, right? And your house as a host. Your house is a host. उस host के अंदर your drawing room is your hypervisor, which is VMware or VirtualBox. And then जो मेहमान आके बैठे हैं, those are guests, and you have your guest in your drawing rooms, right? So that's, I mean, if it might be easy for you to think, and that's how I remembered it when I back in the days. So so your host machine is your Windows machine, physical machine. You install hypervisor, which is your drawing room, and then you have guests, which are your you know, guest OS, guest operating systems. So now with virtualization technology, I can run another Windows machine on my Windows machine, or I can run a Linux machine on my Windows physical machine. I can host any type of guest on my, you know, host machine. So please remember that having this understanding of what is host, what is hypervisor, and what is guest, it is very important when it comes to exams. Okay, so one of the powerful feature of cloud environment is the ability to scale resources. So now cloud environment is very big than your physical machine, and you know, we're talking about multiple users, multiple customers are using that virtual environment, right? So while the ability is incredibly helpful to manage fluctuating resources, it may take asset management a nightmare. Now, we talked about individual machine. Now think about cloud. Think about physical layer in the cloud. There are thousands and thousands and thousands of servers, physical servers running in a data center. And on those thousands of physical servers, virtualization technology or hypervisor is running. And on those hypervisors, maybe, you know, hundreds and thousands of virtual machines that are running. And those hundreds and thousands of you know, virtual machines are accessing thousands of physical servers. In that scenario, resource management can become a nightmare. How are you allocating resources? How are you deciding which customer will get more resources than other customer, right? So now those are the challenges now that cloud service provider has to deal with. That how they're gonna allocate these resources in a way that, you know, it doesn't impact on their operation. Number one. Number two, it does not violate the SLA that they have with customer. If they have an agreement with the customer that in a given amount of time, they have this amount of resources always available for them at their disposal. And now, because of bad resource management, cloud service provider is not able to provide that, then they are in trouble, right? They're gonna lose customers because customers are gonna say, you know, these guys, they are not, you know, fulfilling our requirement, so goodbye to them, and they're gonna lose business. So one thing you need to remember from the examination point of view, most of the questions or majority of the questions will be from business point of view, whether it's from the cloud service provider or from your customer, from management point of view. So you have to have that mindset in the exam. You do not have to have you definitely have to have a technical mindset when you're answering the questions, but on top of that, you have to have that management and business oriented mindset as well when you're taking the exam, because ISC Square exams, CCSP exams is very focused on how businesses are looking at this investment in the cloud, right? Okay. So one of the powerful feature of, okay, so now scaling is very important. So now you have a virtualization, you have a management plan that you're giving out to your customers, and they can set up machines, they can set up network, but they need to, you know that they can manage these resources easily and without any issues. So the next thing is containers. So we talked about VMs. Now think of VMs. So you have a host machine, which is an operating system, hypervisor, which is a drawing room, and then guest OS, right? Which is a full-fledged another OS running in hypervisor on a guest machine. Now, if you think of it, if you want to run an application virtually, right now in virtualization technology, you have to provide the complete environment, including the OS, right? So which can be expensive because you have to sometimes pay for the licensing fees of the OS that you're running in virtual environment, number one. Number two is that since if you want to use a virtual machine for running some application, you need to have a full OS in guest operating system running. And that guest operating system obviously will have more demand on the physical hardware, right? It needs more RAM, it needs more CPU, it needs more graphic memory and all that. So it can be costly, right? Because in order to run one application, you need to install a full operating system, and that full operating system is using a lot of things, it's resource heavy on the physical machine. And that's where containers comes in. So containers are basically, you can say, a dialed down version of virtual machine. What it means is that, say, for example, I need to host a web application. Now, previously with VMs, I need to install operating system. I need to install a web server. I need to install, for example, if this application is PHP, I need to install PHP and all components. Now, in container environment, I don't need an operating system. All I need is a specific environment that does not rely on virtual operating system, but it does provide all the necessary components to run that application. And those components will just directly communicate with the physical operating system or physical device to extract the resources that they need to run. Now that container does not need additional resources for guest operating system. So you can say that it is a slimmed down version of virtual machine, and that makes life much more easier. So you've heard about Kubernetes, and there are other technologies that help set up containers, and it's much more easier. And you can set up containers in your personal computer as well, and they are much more easier. They're much more light on using your resources, and they are just there running in the background, so you don't have to worry about it. And that will obviously resolve your issue of having license to run another operating system as a virtual machine on your physical machine. So as you can see, so VM is next up, and package only necessary code configuration and resources to run a particular application. So unlike VMs, containers does not run an entire OS. Instead, they use the kernel of VM or the OS that they are hosted on, right? So it makes much more easier, much less costly to run an application in containers than in VMs. So VMs provide virtual environments that allow organizations to run their organizations, while containers isolate an application from its environment and allow the application to be run in multiple different environments. The containers are increasing popular technology, especially for multi-cloud and hybrid deployment. So you have heard of, what they call Netflix and all these big companies. It used to be the application deployment model was used to call VMC model, where you have a third tier, you have a web interface, you have a middle tier, and then you have a backend. And those applications are called monolithic applications because everything has to be run in one or multiple servers all together. But now applications are not monolithic anymore. Applications are component-based, and components of applications run in containers, right? So for example, you go to a website like Amazon, it has a feature for cart, it has a feature for various features, and all those features are running their own are individual components running in containers. So if any update that needs to be done to a particular feature, developers only work on that feature and then push that out, and application is working without any downtime. Previously, under monolithic application ideology or architecture, if you have to push out update, the whole application needs to get updated. There was a downtime, and there's a whole different issues associated with that. And now those are not big of an issue with adoption of containers and adoption of component-based application architectures. Okay. Any questions so far? Okay.
One thing about Dockers. Can you clear about Dockers as well?
Yeah, so Dockers, thank you. So Docker is the word I was looking for. Kubernetes is basically for orchestration. Sorry, good question. So Kubernetes is for orchestration. It's an orchestration engine. And Dockers are basically containers. Thank you for that correction. I completely forgot about that. So you use Kubernetes to automate containers, which are Dockers. So Dockers is actual containers. And Kubernetes is orchestration engine, which allows you to set up containers in Dockers automatically. So you set up, and you can actually download various Docker containers from their website. All you need to do is set up Kubernetes on your machine and download containers or from Docker website. Remember, I'm not sure if you have worked previously with VMs. VMware used to offer various pre-built virtual machines that you can download and just run it in the VM. You don't have to create it, they're pre-built. Same concept. You can actually download multiple containers, applications in Dockers, which are called containers, and run it on your machine. And you do not need an operating system. So yeah, thank you, but that was a good question. So containers are individual components, and Kubernetes is basically what is the orchestration engine, which basically automates this process of creating those containers. Make sense? Does that answer your question?
Yeah, thank you. And mostly we are running Dockers on Linux, right? We need to know Linux when using
no,
these.
you can run Dockers on Linux and you can run Dockers on Windows. They are available on both platforms.
Right. Thank you very much. Yeah.
Yep. All right. So the next one is reservation limits and shares. So this one is, from the examination point of view, it is extremely important to understand these concepts, because you will get scenario-based questions on reservation limits and shares in your exam. And having this understanding of this concept is very important from examination point of view. So let's talk about reservation. And these are all cloud concepts. And when you are working with your cloud service provider, when you're drafting up an SLA, which is a service level agreement with your cloud, you need to understand these concepts. You need to make sure how that contract, how that SLA is documented, how the reservations are being talked about, limit, and how the share is being used. So let's talk about reservation. So a reservation guarantees that a cloud customer has access to minimum amount of cloud compute resources, that is CPU or RAM. Much like a restaurant, reservation ensures that you have a seat when you need it. Make sense? So when you are getting a cloud service, reservation is that you tell them that, hey, to the cloud service provider, that reserve this much of various resources or various services for me. And cloud service provider will then allocate and reserve for those resources for you whenever you need them. So that's basically a reservation. Just like you go to a hotel, you reserve a seat, a restaurant, and you go and use that seat and enjoy that time at the restaurant. Next one is limit. And again, from the idea of resource management that we were talking about previously, that resource management in cloud computing is extremely important. You just cannot, set up a cloud service and do not do any resource management. If you open everything up, what's going to happen is that, everybody is going to rush for resources, and there is no management, there is no limit, and things going to come down to a crushing halt. So that's why limit is very important. So a limit acts just as opposite of reservations and set a maximum amount of cloud compute resources that can be used. So let's take an example of network bandwidth. Now, if I want to use network resources on a cloud service provider, cloud service is saying, okay, you can only use 20 gigabytes in a month. Just give an example, it may much more. Now, so that's my limit, right? Once I reach my utilization of that 20 gigabyte in that month, then I'm done. I cannot do anything more unless or until I pay them more, revise my contract or whatnot, and then they will increase my limit. And that's what limit is in cloud service provider. And that it allows you to manage your cloud resources in a much better way. So limits can help customer ensure that they don't use more resources than they have budgeted for. And they can also help ensure that a single cloud tenant does not use a tremendous amount of resources at harm of other tenants, right? Take the example of apartment building, if everybody has a limit on how much resources they can use, gas, water, electricity. So those are resources tenants are using in a building. Now, if building has only one tank of water, then and one tenant is using majority of that water, I don't know whatever he's doing, then other tenants will not have water for them to use. So then you have to have limits. You have a water tank, you calculate how big is the water tank, and then you divide that water tank utilization among all the tenants in that building. So that's how you manage that big resource. Otherwise, you're gonna hear a lot of yelling and screaming from your tenants that, hey, one guy used everything, what are we gonna do? So that's a nightmare, right? So that's how you put limits. Third is share. And the concept of share is used to mediate resource allocation contention. So resource contention, so important concept. So contention means, we are fighting for resources. Contention, that's what contention means. You have one resource and now everybody is fighting for that resource. And to avoid that, business have to pay for everything. If you are, using a cloud service provider, there's a question. The question is, business have to pay for reservations, and business have to pay for limit. They have to pay for both, right? You need to understand your requirements, how much resources you need. You need to reserve those resources, and then you need to understand how much utilization you can do, so that you also can limit that, hey, my users cannot go beyond this limit, because it's a business decision. So we talked about from the cloud service, one good question actually, but from the business point of view, you need to also think, because if you are using cloud services, you are paying for it. And using a cloud service is an expense, right? Now, if you do not have a limit on your users enforced through your cloud management plan, the user is going to use any bit of data they're going to have access to. So you need to restrict that, right? So yes, so limit, the idea of limit is all, not only from the CSP side, but also from the business side, because it has a financial impact on the business. All right, going back to share. Good question, thank you. So the concept of share is used to mediate resource allocation. So resource contention is just a fancy way of saying that there are too many requests and not enough resource available to supply all those requests, right? So when resource contention occurs, share values are used to allocate resources to all tenants assigned a share value. So tenants with higher share value receive a large portion of available resources during that period. So again, so they do a method in share resource, in the share concept, that who will have more access to shared resources than other tenants. Again, that is determined based on the client business requirement, client usage of resource requirement. And that way, whoever pays more to use our given available resources will have access to share more than the rest of the tenants in the given amount of time. So that's the idea of share. I mean, we'll take the example of, apartment building. So the guy who lives in a penthouse must be a rich guy, right? There's a big business tycoon, he has a lot of money and he has a bigger apartment, but he has to, share, again, the same water tank. So what he's gonna do, because he's a rich guy, he has more probably use of water. I don't know what he was doing. He may be taking baths every day or every hour, I don't know. But he can pay management that, hey, for this amount of time, I need more water than these people. And then he has to pay for that. So management of the building reserve that water, more water for him during that given amount of time. So the question came in, if during agreement tenure, more resources needed like service capacity, will it be processed or need to wait till agreement ended? So no, it can be contracts and SLAs can always be revised. And then the flexibility is usually built in the contracts. And these are the things, these are very good questions, that these are the things, being a security cloud architect, you need to consider when you're working with organizations and providing that advisory of what needs to be done. And these are exactly the same questions that you think, and then you make them part of your contractual language. So you can say that, during Eid time, during Christmas time, we will have more requirements of resources, more requirements of data, because you are an e-commerce company, you're selling stuff, and we all know that during holiday season, whether it be Eid in Pakistan or Christmas in other countries, you need more resources. So during that time, you negotiate those things in the contract. And then you can add resources as needed. But you have to pay for it. Obviously, nothing is for free. All right. So we briefly talked about virtualization. We talked about containerization. So let's look at a little bit more detail into virtualization, because you're going to get questions on virtualization and specifically around the security of virtualization, right? So yes, virtualization is a great technology, right? You can do abstraction, you have one resource is being distributed to multi-tenant, but with all these facility of virtualization, there are security aspects that needs to configure, because virtualization is not all and good when it comes to security. When I'm just going to talk about a security concept, which is called attack vector. People who are in security understand what attack vector means, or attack surface means, sorry, not vector, attack surface. The more things you're adding into your application or into your environment, what you're doing is you are increasing the attack surface. What it means is that now you have to manage more things. Now you have to make sure that whatever you're adding, you need to increase the security, because now hackers or malicious actors have more things to attack on. Their surface of attack has increased. So now, as their surface of attack increase, now you have to increase your security control implementation or security management. So virtualization increases the attack surface. Before virtualization, you're only worried about guest OS. You're working about physical machine. Now you have introduced hypervisor. Now, hypervisor increases the attack surface on top of physical amount. You need to now make sure your hypervisor is up to date. Your hypervisor is configured properly. There are no guest OS escapes that are happening from hypervisor. You need to make sure the guest operating system is completely isolated from host operating system. So if guest operating system is compromised, the hacker should not pivot into your physical network. So these are the considerations now as a security professional, as a cloud service provider, you need to think now. So virtualization is all in good, but increases attack surface. So increased scalability. So virtualization environments are designed to grow as your demand grows. They're very elastic, they're very flexible. We talked about, limits and all that. So if more requirement comes in, your cloud service provider, you have 10 virtual machines running, your demand increases, you say, oh, we need more machines. You go to cloud, you spin up more machines, and you're in business, right? Allow faster resource provisioning. You can quickly set up you can spin up machine like within a matter of minutes. Imagine that if you have to set up a new machine, you have to buy a physical machine, you have to install RAM, disk and all that. And then on top of that, you have to buy a license, and then you have to put a CD in, and then you have to install operating system. It takes a lot of time, right? Virtualization makes it quick in cloud. You need a new machine, Linux machine, Windows machine, whatever the case may be. You go to your management plane, you log into your web interface, you select the machine, and the machine is there for you to use like in minutes. So it's fast. Reduces downtime. Again, if, virtual machines, you take snapshots. So for example, your machine is corrupted, whatever the case may be, you can revert to the state where the machine was working in the matter of seconds, in the matter of minutes. So it reduces your downtime. If you're in your physical machine, your hard disk is blown out, or your RAM is not working, or your processor went out, you have to order it, it comes in, and then it increases the downtime, right? So virtualization reduces the downtime from that perspective. Avoid vendor lock-in. So we talked about vendor lock-in, and vendor lock-in is something that you also need to consider when you are selecting a cloud service provider. You do not want to have a vendor that gives you a very specific data format that only works in their environment. Because if you're storing data in a specific format that only works in a specific cloud service provider environment, then you're locked in with that vendor because you cannot move. You have lost portability. So for example, you have database that is set up in an AWS environment. An AWS database is a very specific database. It has a very specific format, and it only works in AWS environment. Now, next year, AWS has increased their prices, and you said, nah, it's not in my budget. I don't want to work with AWS. I want to look for options. So you go to Azure. Azure said, yes, we can give you good rates. Why don't you come to us? Now, if you are going to move your data, you are locked because the data is in specific AWS format and it cannot work on Azure. So that's what vendor lock-in is. So you need to make sure whenever you're selecting cloud service provider, portability is the key. And portability is that you use data formats that can be moved from one cloud to another cloud without any issues. So virtualization basically helps you in avoiding vendor lock-in because it abstracts software from hardware, meaning your virtualized resources are more portable than their physical counterparts. Unhappy with your vendors, pack your VM machine and move to another cloud vendor. And you have seen that, if you have a physical machine, because virtual machine is just a file on your computer, nothing more than that, right? You can just copy, that file on a USB stick from one computer, put it on another computer, spin up your virtual machine, and you're in business. No issues whatsoever. Saves times and money. Virtualization resource can easily be centrally managed, reducing the need for personnel and equipment to maintain your infrastructure. In addition, less hardware usually means less money. So we talked about it. It's very easy, it's cheap, it saves you time, and it saves you money. Anybody wants to take a break, 5 to 10 minutes break, and we can start later, or you want to go on?
I think so. We should carry on.
Carry on? Okay. All right, next slide. All right, so this is, again, this is another very important, you will get questions on different type of hypervisors. So what are different hypervisors? So if you look at it, you know, hypervisor is your drawing room where you put your guests in. So hypervisor abstracts software from hardware and allow each of the guest OS to share host hardware resources. So while giving the guest the impression that they are alone on that host. Now, so there are two categories of hypervisors, type 1 hypervisors and type 2 hypervisors. Type 1 hypervisors are the hypervisors that do not require a guest OS. They run on bare metal computer. So VMware has you know, bare metal hypervisors. I do not know the name. If anyone knows the name of those hypervisors, please feel free to share. But you know, VirtualBox is a type 2 hypervisor because VirtualBox requires a host OS to run and install on it. So now if I ask you a question, so let me ask you a question. Which hypervisor, in your opinion, is the most secure type of hypervisor? It's a question for all of you.
Type 1.
Why?
Because it's removing the host OS, so it's actually reducing one layer of surface of attack when reducing the scope of surface attacks.
Exactly. So in the questions, you will get this question about which hypervisor is more secure, and type 1 hypervisor is more secure hypervisor to be implemented in a cloud environment. Why? Because it reduces the attack surface. We talked about attack surface just a few minutes ago. And that's exactly the reason. So if you have type 2 hypervisor, then you have to worry about patching the host OS, you know, updating the software and all that. So a type 1 hypervisor is bare metal hypervisor, and it is run directly on the you know, hardware, and it is more secure. Very cool. All right. So what are we already talked about the security challenges, so we just go through it really quickly. You know, hypervisor security, we talked about it. VM security, then you have to run virtual machines, their security, you know, making sure image is properly set up, you know, making sure the files of VM files are properly secure, they are confidential, because you cannot just leave virtual machine files on a hard disk openly, because if you do that, then anybody can have access to those machines. They can make changes to it, and that will introduce you know, threats in your environment. So you need to make sure that whatever VMs you are setting up, they are locked and secure, right? Network security, again, virtual machines have their own security, which is software-defined network. We talked about it. We need to make sure that software-defined network is properly set up, network security is properly configured. I'm sure whoever has worked on hypervisors know what is a host-only security, what is bridge security, bridge network configuration, and all that. So you need to think about those things, and resource utilization. So if you do not have a powerful hardware, then you know, you're not gonna get a good machine. All right, next one, storage. So we talked about compute, we talked about virtualization, now it's the storage. These are all components of cloud computing. So volume storage is the hypervisor takes a chunk of physical storage infrastructure and virtually assign it to virtual. So volume storage is just like in your C drive, you know, in your computer, C is a volume, D is a volume. It's just the type of storage, right? And usually these machines use volume as a storage. So we all know, we all have seen what is a C drive, what is a D drive, and how it is set up. And if you need to access any file, you need to have a proper address location to access those files. And it has a table in the background which index everything that is stored on volume storage. So that's in a nutshell is volume storage. Object storage is what we use on cloud a lot. So object storage is a bit newer concept than volume storage, and it gives developer additional option for storing and retrieving unstructured data. So object storage is ideal for images, documents, web pages, and other data without specific schema or structure. So volume storage is much more structured, much more organized. Object storage is not that structured. You can store anything on this type of storage, and it will see everything as one entity, right? It's just a file. It does not matter if it's a VM file, it's a document file, image file, or whatever. It doesn't matter. No matter what is the structure of the type you're storing, it will have keys and indexes, and it will access that data just like that without knowing what type of data it is. So object storage is what majority of the cloud service provider use. I think S3 bucket is also an object storage type service. We talked about management plane. Just to quickly, it's just a interface that allows you to access various services, and only administrators should have access to management plane. Not everybody should have access to it, because if your management plane is compromised, then obviously your whole cloud infrastructure can get compromised. So give me an example of one security that you can implement at management plane level. Any idea? How can you secure management plane? Okay, so management plane can be secured via two-factor authentication or multi-factor authentication. So that first of all, you only have limited number of admins, and then whoever have access to it has to use two-factor or multi-factor authentication, because simple username and password makes it more vulnerable. Okay, so most modern cloud provider exposes management plane to its customers to the set of APIs. As I mentioned, everything in the cloud is API based, whether it be through web interface or through CLIs. So AWS referred to there as a management console, cloud named it as Cloud Console, while Microsoft call it Azure Management Console, Portal. So these are the names of management plane in these major three cloud service providers. Okay, analyzing risks associated with cloud infrastructure. So we talked about general components of the cloud in the previous slides. What are they, how they connect together, and what are different services. Now we're going to talk about what are the risks. I mean, we talked about risks as we were going through, but we're just going to talk about, in general, analyzing risk associated with cloud infrastructure. First one is reduced visibility and control. So customers who host and maintain their own infrastructure maintain complete control over the security, for better or worse, right? Because you have your own data center, you know what that data center is, you know what type of networking is, you know what hardware you're running, you know what firewall you're running. So you have that visibility at the physical level. So you have end-to-end visibility in your own structure. But when you're going to cloud, that end-to-end visibility in the infrastructure is no longer there, right? You are giving up some control to cloud service provider. Okay, Mr. Cloud Service Provider, we trust you. You have your infrastructure, you have your physical environment. We don't want to know what's going on and everything. You manage it. It's not our headache. Yes, it's not our headache, but you're giving up control. So that's one of the risks that is associated with cloud infrastructure when you decided to move to cloud infrastructure. And how you mitigate that risk? You mitigate that risk with SLA, service level agreements, right? You write the service level agreements in a way that, cloud service provider takes the responsibility, because cloud service is a shared responsibility model. It's not individual responsibility model. So you need to define what your responsibilities are versus what cloud service provider responsibilities are. So all those things, although you're getting up controls, all those things need to be addressed in the service level agreement. Okay. Second challenge is, second risk is staffing and operational challenge. Again, it relates to that. You're giving up control. The staffing that you used to have in your data center, you do no longer have that anymore, right? You do not know what type of people who are working on your in the cloud environment, because they are not your employees anymore. If they have proper background checks, who are the people, how technical savvy, how good they are the skillful people who are managing. So you are giving up all that control, right? Also,
So
go ahead.
I do have one question.
Sure, go ahead.
About PNDP, privacy and data protection, and also about PLA, all these things, and data discovery, classification, everything is covered in SLAs in case of cloud.
Everything is. So data, so remember one thing. So for example, if your organization has a requirement, a privacy requirement, which is you have to comply based on whatever the regulation you need to meet, whatever the industry, maybe it's the healthcare industry or financial industry, the ultimate data responsibility lies with you, not with the cloud service provider. So you need to be, so you cannot, so for example, if your data got hacked in the cloud, right? You are, as a cloud service customer, is responsible for that data. You are responsible for all that comes after the breach happens. So you need to be very careful in documenting that SLA. Ultimately, responsibility is your organization. But cloud service provider has also shared some responsibility, but litigation or if anything happens, you will be dealing with that, not cloud service provider.
Specific to data, right?
Specific to data, yes.
Yeah, thank you.
Yep. All right, so vendor lock-in, we talked about, before we move on, staffing and operational talent, yes. So this is something that I have been seeing with my clients more often, right? So what happens is that now, companies are moving towards cloud. A lot of their infrastructure, a lot of their applications are moving into the cloud. So what the gap that I'm seeing, and that's what I'm helping my clients with right now is that how to adopt that cloud security mindset, because at this point in time, all of their policies, all of their standards, all of their procedures are documented or not documented at all based on older model, which is on-prem model, right? Their physical security policies and procedures, their firewall policies and procedures or whatever and whatnot, they were documented. And then they moved to cloud. They never updated their policies to reflect that change. They never updated those standards to reflect that change. And now most of their policies and standards does not make any sense because they don't apply in the new environment. So now they need to rewrite, revise those policies, revise those standards. So that is something that I'm working with my clients to update those, number one. Number two, most of their employees that they were working with, they are very accustomed to working on-prem data centers, right? On-prem everything, on-prem security, on-prem physical environment and everything. Now things have moved. What happens? They probably have to let go some of the employees who are not updated. They hired new people who are more in tune to cloud environments and understand nuisance that cloud has, right? So those are the things, or they need to train their existing employees so that they understand how cloud works. So moving to cloud is just not as simple as it might think. It has a lot of baggage that comes with it, and you have to address everything. Vendor lock-in, yes, we talked about vendor lock-in. I do not believe we have to go over it again. Okay. Compliance and legal risk, I think you just talked about it. So when moving to cloud, you transfer some responsibility for protecting your infrastructure and system, yes. However, you are not transferring liability, and liability comes with what we just talked about, data. UNDP, not UNDP or whatever the term that we use, unless your contract with CSP states otherwise. You're still legally responsible for ensuring compliance and legal regulations requirement that impact your data, right? So you are ultimately responsible for that. Compliance is a huge point of contention for cloud customers, and it's insanely important that you as a customer perform your due diligence when moving to cloud customers. So it's not the cloud responsibility, it's your responsibility. You need to understand as a cloud architect what your organization compliance requirements are before you select a cloud service provider, because you need to make sure that the cloud service provider meets those requirements that your organization has, right? So some CSP officers customer a document called a customer responsibility matrix, and you can ask your cloud service provider, they will give you a matrix, and the FedRAMP and HIPAA in US at least. So these are the compliance requirements that you need to look into. If you are dealing in healthcare industry, if you are in federal government, then you need to make sure you select the cloud service providers that can help you to stay in compliance with these requirements. Any questions? Okay. So cloud vulnerabilities, threats and attacks. Again, as I mentioned, the management plane is very important. If management plane is compromised, your whole cloud infrastructure can get compromised. So because management plane is the most valuable attack target, that highest resource of risk in the cloud environment. So importance of management plane is absolutely critical when you're moving into a cloud environment, because it's a single interface, it's a single point of failure, I guess, because if it gets compromised, then everything is compromised, because a malicious user or actor has access to everything in the cloud. Incomplete data deletion and sanitization, that's another, and this is important specifically in case where you have very specific data requirements, compliance requirements, data retention requirements, that after a certain amount of time you need to delete your data. So cloud, since it's a very distributed environment, sometimes it is very difficult to control that aspect of it, because you can delete it from one area of the cloud, but the data may reside in another area. So you need to be make sure that your cloud service provider do not distribute your data. It might be physical location, geographical location, whatever the case may be. For example, the US government over here doesn't allow data to leave in US geographical boundary. So data that belongs to US government cannot be stored in the data centers of the same service provider in Canada or in South America. It is not just not, so that when it comes to data deletion, when it comes to PII, PHI, or credit card holder data, the data complies with that geographical requirement. And if the data needs to be deleted or sanitized, it can happen at one place, and you don't have to search and chase the data all over the place. Insecure multi-tenancy, you're going to get a lot of questions on multi-tenancy and security. So we need to make sure that the security between different tenants is properly set up. They are properly segregated, and one tenant should not be able to go into another tenant's environment and see their data. And this happened in the early, when the cloud was in infancy, where one customer or one tenant was able to pivot into another tenant and was able to see the data. So we need to make sure that a multi-tenancy is properly set up, resource sharing is secure, and one tenant should not be able to access the environment of another tenant, because they're all hosted on physical machines. Resource exhaustion is another risk. We talked about resource. So we need to make sure that resources are properly allocated and they are not fully utilized, so that resource gets exhausted and you cause yourself a denial of service attack, because when resources are exhausted, they are no longer there for users to use. So service will not be available. Network host and application vulnerabilities. Again, as with any computing system, cloud environments are made up of hardware and software that might contain security vulnerabilities. So in terms of cloud infrastructure, CSPs are responsible for routine scanning and patching of hosts, network devices, databases, and applications under their control. And you can see that Azure has a security service that you can log in, and it will allow you to scan all your devices, whether it be host machines or network devices. Azure also has a compliance and security dashboard where you can log in and you can scan your cloud assets, and it will give you a report, and that will show you where your security is, where patches are missing, where misconfigurations are, and so they can take proper actions to do that. And tools like Nessus and Qualys, the vulnerability scanning tools, they are now cloud enabled, which means that you can scan your cloud assets from your physical device in your organization. All you need to do is just provide an API, authenticate to your cloud environment, and do the scans, and it will just work as you're on a physical machine. Virtualization risks, again, architectural risks directly related to abstraction between physical hardware and virtualized systems, lack of visibility and control over virtual networks. Again, if the virtualized traffic is not monitored properly, then you do not know if attacks are happening, if there's an IDS or not, it's not properly set up, then malicious traffic can be on your virtual network. Resource exhaustion, we talked about. Workloads of different trust level and same host. Again, workload is due to multi-tenancy and resource pooling, and risk due to CSP APIs. So API is very critical, because API is what binds all the service together. So if API is properly not secure, then your cloud service is at a risk, whether it be virtualization, software-defined network, storage, compute, whatever it is. Everything is, consider APIs as a system of roads, right? So which connects one part of cloud to another part of the cloud. And that security is very critical. If that road is broken, if that road is compromised, then your whole system is compromised. So API security is key, and where you install API gateways, API firewalls, API identification or authorization, API logging, all those areas of security that you need to consider when you're selecting cloud service provider or setting up one. We talked about hypervisor software security risk. Are we good, or should we stop, or should we go on? What do you guys think?
I think so. We are good. Anybody wants to stop?
Okay, I think we can. We should be finished with another 20-25 minutes. Are we good for that time?
Yeah, I think so. It's fine.
Okay, let's keep on going then. So hypervisor software security risks, if not managed through its entire cycle, the hypervisor may contain exploitable vulnerabilities. Again, in type 2 hypervisor, that is a big risk. You can reduce this risk by using type 1 hypervisor. Unauthorized access to hypervisor, again, hypervisor is the holy grail of virtualization. So weak access control mechanisms present immense risks to cloud customer and their data. Configuration risk. So I briefly talked about configuration risk, but what it is that, so remember these terms, VM sprawl. This is a very important terminology from the examination point of view, that, they will give you ask, what is a VM sprawl? And they'll give you, various options to select what. So VM sprawl is the uncontrolled growth of VMs to the point where cloud administrator can no longer effectively manage and secure them. And why VM sprawl happens? I can give you an example. And mostly in development environment, developers like to create machines here and there, right? Oh, I need to test this software, spin up a virtual machine. Now, if it is not properly managed, what happens is that you're going to have tons and tons of virtual machines in your cloud environment, which you have no control over. You do not know, you have no proper asset management. And when that happens, when you do not know where your assets are, when you do not know how many virtual machines, you do not manage them, then it will introduce risk of, due to lack of patching, because you do not know what virtual machines are out there. You do not have asset management in place, right? You do not know what type of access control is set up on this virtual machine. Some of your machines just may have, admin control on them with password as a password. You do not know. So it is very important to control the number of VM machines, and whatever the VM machines you are creating, you need to know where they are, who created it, when they are created, and what function they are doing in your organization. So now most of the cloud service providers, they have automated a way of letting administrator know if a VM machine come online. So those automated asset management is very key in managing these VM sprawls in your cloud environment. Then sensitive data within a VM, because VM are just files, right? It's just file. Anybody can, read those files. And if there is any sensitive data in those VMs, that can get compromised. And what is one control that you can implement on those files? Anybody? So that sensitive data doesn't get compromised.
Encryption.
Exactly.
Encryption, yes.
Exactly. So you can encrypt VM files. And when you want to spin up that VM, what happens is at the time of spinning it up, it will ask you that password to decrypt that VM file. So Hypervisor will take the password and then decrypt that file and run that machine for you. So what it is saying is that because VM is a file, it is stored on a disk somewhere in the cloud, it needs to be encrypted so that, you know, nobody can get the data.
So about one thing, like we do have like different storage types like volume storage and object storage. So we are encrypting the VM, right? Does it mean that we are also encrypting the data that is stored somewhere in the storage in the cloud? So just encrypting the VM.
So yeah. VM inside will have volume storage. When you spin up a VM, right? So VM has storage in it. So it has its own storage that you have allocated to that VM, right? A C drive, right? Because you are running a virtual Windows 10 as a virtual machine, you spin it up and the storage that you have allocated shows up as a volume, as a C drive in that virtual machine, right? But virtual machine file itself may be stored on an object storage.
Okay,
right?
okay.
And then in that object storage, that VM has inside a volume storage. But to computer, it doesn't matter. To computer, it's just a file. The whole VM is a file. It's a set of configuration parameters that set up that virtual box. That's about it. And in that, you know, there's data. As you know, if you add more data to a VM machine, the size of the virtual machine file increases because you are storing more data. So that data is part of that whole thing. So you have to encrypt that file, a VM file, which might be storage on an object storage.
Yeah, so yes, thank you very much. So it was point of confusion for, I was reading about like bit splitting technology and things like that. So I was just thinking maybe how would cater that as well. So,
okay.
Anyways, it's okay.
Okay. So am I able to answer your question? Is it clear?
Yeah. Thank you.
Good. All right. So for example, the container's underlying security host OS may be compromised and process data within the container within the broader containerized environment. You probably won't get any questions on containers. I didn't get any questions on containers. I did not see much questions in practice, but you will definitely get questions on virtual machines.
What are the sample exams or the questions which we can prepare for the certifications? Any specific vendors?
So I have actually, let me show you.
Can we take this question at the end because it will kill?
We can take. Yep. Okay, next one. Okay, so designing and planning physical security, all they talked about it. I don't think so we need to talk about it again, but these are basic physical controls for data centers, and you need to make sure then when you're talking to CSPs, these controls are in place. So nothing new here. We talked about system and communication protection. If you remember in my previous domain lectures, we talked about data at rest, data in transit, data in use, policies and procedures, logging and monitoring. So data at rest is the primary security controls are protecting confidentiality at rest and encryption. Again, you can think of an example. We just talked about VM machine security, right? So if VM machine is a file, it is stored on an object storage, then that is a data at rest because it is just sitting there doing nothing. So how you can secure it? Encrypt it. Data in transit, the data that moves between computers, right? So HTTPS and TLS traffic encryption, that's how you secure that data that is moving from. So let's take an example of management plane. So if administrator is accessing Azure portal, we need to make sure that communication is protected. So from the web browser to the server where the management console is being accessed, the data is encrypted through and through, right? So data in use is protected through encryption, digital signatures, and access management controls across all APIs. So this is the data that is currently being used in one form or the other. So if you're spinning up a machine, you have spun up a machine through management interface, and make sure, because it is an API call, API communication, you need to make sure that those APIs that are communicating with the virtual machine or SDN network, they are properly secure. The API security controls should be in place. Policies and procedures. Yes, go ahead.
One thing here, we are talking about encryption. How about using anonymization or masking?
Yes,
or
so those are all aspects of data in use. You're absolutely correct. So tokenization, anonymization, those are all examples of protecting data in use. And we discussed those in detail in our previous domain when we talked about these aspects. So you are absolutely correct. Tokenization, anonymization, there's all example of data in use. Isolation, security, isolation of security functions from non-security functions, which is very important. Logging and monitoring, obviously, anything that is happening on the cloud service, on a cloud provider, we need to log and monitor for various purposes. Okay, the last topic is business continuity and disaster recovery planning. It is pretty much exactly the same as we do in your organization. So the core responsibility of information security professional, so business continuity efforts are a collection of activities designed to keep business running in the face of adversity, right? I mean, that's what the name implies, that's what business continuity is. If something happens, we need to make sure business goes. We do not afford a large amount of downtime. So this may come from small scale incidents such as single system failure or catastrophic incidents such as earthquake or tornado. So business continuity plan may also be activated by man-made disasters such as terrorist attack or hacker intrusion. So anything can happen. It could be a natural disaster or it could be a man-made incident that happens, and that will impact on your business. Your business just stopped working. Because if business stopped working, imagine Amazon going down. They're going to lose business left and right if something happens to their data center. They need to have a continuity that if something happens, then business just continue as usual without any downtime. Because I'm sure millions and millions of dollars of revenue will lost in a day for Amazon if anything happens to them.
But isn't it that this is covered by the SLA where you will put up the machines and what the contract you have with the CSP? For example, in US East Region 1, some attack happened and this data center and their availability zones goes away, completely vanished, like an ash burn or something. Sure. That's not the responsibility for Amazon. Except that the other side, the data will be available because the VM which we spin it's a part of only the US region 1, and that where we bought the services and stuff.
No, but US has multiple regions, right? US is huge, right? So you might have data center in East Coast, but then you have data centers in West Coast and Midwest. Everywhere.
The data centers are available, no doubt, but the contract or where you will spin your VM, for example, my company is I just put it into the US 1 region. I don't see that I need to put it into the US 2 or the South region or something. So that's the part of the SLA that Amazon will provide only this region, the availability, because within the US East region, there will be the different availability zone also.
Yes, exactly. Exactly. So that is part of the SLA. You need to understand how your SLA is written. You need to understand your business, and that's where business impact analysis comes in, right? If you have not done business impact analysis, what happens if US zone 1 goes down and your SLA says, okay, we've only guaranteed US zone 1. Now, something happened at Amazon, you're not able to access your data. Then, your business suffers, right? So that's the vision, that's the understanding that you need to have. What happens if US zone 1 goes down, right? Then it's up to you because it's your business. You're using somebody else, but it's your business going to get impacted. So in case US zone 1 down, what is Amazon going to provide you? right? So that's what needs to be documented from your perspective. So not this business impact analysis, we're not talking about Amazon. We are talking about you as a business, as a customer, right? So BIA is a risk assessment that follows one of a quantitative or qualitative process used by risk managers. So the BIA begins with identifying the organization, critical business process, and then tracing those backward to critical IT. So you as a cloud architecture, you might not be doing business impact analysis as a whole, but you will be working probably your risk assessment team or risk management team, and to tell them that, hey, if this happens, I see a risk here, and then let risk be an advisory to your risk management team, right? So being a cloud, yes.
So it's not necessary that it's a risk management team. It can be like business continuity management team.
Yeah.
So yeah, so we do have here in my company, I'm running this whole setup of business continuity management. So we are also looking after the risk as well. So risk as per ISO 22301. So they have a different risk methodology. So it could be not necessarily the risk management team. It could also be the business continuity management team. And one more thing is that when talking about this business continuity thing, we need to focus on the crisis, not on incidents. So when you're talking about like IT incidents, it's very hard to cover it in business continuity management things. So we are talking about crisis mostly in case of business continuity management. So yeah, so this is what I'm telling you with respect to my experience with business continuity management. So if you're focusing on incidents, you will not be reaching anywhere. So you
right, and again, I think it depends upon the business of the organization, how their business are, what their business model is, and what is important to them. And that's why you have to have that business impact analysis, understanding what's important for your business, what's not important for your business, and what type of threats or incidents that your business can have. And one part of it is doing a threat modeling, right? And that's what you do. Threat modeling is part of the impact analysis, where you look at, you sit together, you look at what your assets are in your business, you look at what the controls that are in place in your business, and then you look at what the threats are that can compromise your business. So these are all part of this business impact analysis process.
Mr. Rehan, I have a question.
Yes.
When we, let's say when we are going for a VM sort of an environment, right? So let's say when your primary data is corrupted, right? It will again flare back in your VM environment as well, virtual environment and your cloud environment, right? So in those sort of scenarios, how do you ensure that your primary data and as well as the data in your scheduled backup in your cloud environment is also safe?
Yeah, so that's where you have.
Some people propose an air gap model, but what do you suggest would be the best model just to ensure that we have continuity of business?
Yeah, so I mean that's a good point, because as we all aware about ransomware attacks, right? And at this point in time, only prevention or only safeguard that you have against ransomware is your backup, right? Because if your data is encrypted, then either you pay the ransom, or if you have a data backup, then you recover that and you're good to go. So air gap is a good model that will help a lot. Because why we need an air gap model? Because if your backup plane or your backup systems are not air gap from your production systems, then there is a high chance that ransomware can also impact your backups, right? So in that scenario, air gap system is critical. And these days, I think it is very important to have an air gap backup system rather than a backup system that is connected to your production network and doing a backup. So I mean, there's a backup strategy. Either you're doing full backup, incremental backup, differential backup. So those are your backup strategies, however you want to see fit. But then air gapping your backup will definitely increase your security against threats like ransomware. So, but it might be costly, but again, you have to do a business impact analysis and risk associated with it. If your cost versus benefit and cost is more than the benefit, then you probably won't go and you do whatever your database backup practices are. But if benefits outweigh the cost by doing that air gap backup, then obviously go with that approach.
Thanks, Mr. Ham. Thank you so much.
So once planners have identified the effective system, then they identify the potential risk of those systems and conduct a risk assessment. So again, the key is, for all this thing, the key is risk assessment. Identifying your qualitative and quantitative risks. What happens if a threat is materialized, and how much in dollar amounts you're going to lose. Some companies use dollar amounts that they do quantitative analysis. Some companies do qualitative analysis where dollar amount is not involved. So it depends upon the nature of the business on which risk assessment approach you want to do, or you want to take a mix of both approach. As part of business impact analysis, you need to understand if your business is a high availability or a fault tolerance, right? So there are two key technical concepts that improves the availability of system. High availability, known as AJ, use multiple systems to protect against failure. Maybe you have multiple firewalls, maybe you have multiple web servers. So if one firewall or one web server goes down, you have another. So you have heard of red-blue deployments, and that's what Netflix and a lot of big organizations do. They do red-blue deployment. So at one point, red deployment is active and is being used by users, but now they're issuing a new feature. So they deploy everything in blue deployment area. And what happens is that they test few users in the blue deployment, everything is working there, and then they move all the users from red to blue, and then the blue to red. So they switch between them. So that's another aspect of high availability. If any deployment goes down, other deployment is available. Again, there are three tenets of security we talked about in the first domain: confidentiality, integrity, and availability. So high availability and fault tolerance is basically falls under the availability tenet of that CIA triad. You need to have redundancy in your network, in your services. If one goes down, we talked about zone 1, zone 2, USA, and that's where redundancy comes in. And that's where you can talk to Amazon, hey, we need redundancy. If one data center goes down, make sure we can switch to US's zone 2, maybe from zone 1, so that, nothing happens. Okay, so the second major RAID technology is this. Other one is, fault tolerance. And we talked about RAID technology. I think we all familiar with RAID technology very well. What is mirroring? What is stripping? Mirroring is, RAID 1. Stripping is, I think, RAID 3 or RAID 5. And they both work in a different way. Mirroring is basically exact copy of your primary disk. And RAID uses, and RAID 5, level 5 use parity disk, and multiple disks that have a parity data. If one disk goes down, using parity disk, you can recreate the data on the disk that gone bad. Okay, disaster recovery planning. So there, we have done business impact analysis. We know what needs to be protected, but now what happens? A disaster happens. Now, in the disaster area, when you're in the disaster phase and disaster happens, there are three key things that needs to be determined as part of the business impact analysis. That during disaster, what needs to happen, right? How soon the business should come online? How much downtime a company or organization can afford once after the disaster happens, and now we are in a disaster recovery mode. So that planning also needs to happen as part of the business impact analysis, right? So the disaster recovery plan may include immediate measures that get operation networking again temporarily, but disaster recovery effort is not finished until the organization is completely back to normal. So during a disaster recovery effort, the focus of most organizations shift from normal business activities to concentrated effort to restore operations as quickly as possible. So this is the second phase. Now, it actually happened, earthquake happened, or tornado happened, or some man-made attack happened, disaster happened. Now, what you need to do? So there are three key metrics, and this is important from examination point of view. You will get questions from any of these three metrics, and most of these questions that I've seen under disaster recovery planning comes in a scenario-based questions. right? So the three key matrices that you need to understand when a disaster happens is the recovery time objective, RTO. Second one is the recovery point objective, RPO. And the third one is recovery service level, or RSL. And I got really confused sometimes on this one. So I hope you guys don't. So the recovery time objective. So what it is the target amount of time that it will take to restore a service to operation following a disruption. So means disruption happened, that is 0.0. Now from 0.0 to let's say 0.10 is the delayed. Between them, how much time, based on the business risk analysis and the business requirement, how soon company wants to come back to normal? What is their recovery time objective, right? So if it's a very critical business, there's a lot of money is involved, the recovery time objective will be very small window. Now, if a company can, afford a downtime of maybe a week, their RTO is huge, right? So it depends upon the critical, if in the hospital, power goes out, right? The patients that are in operation theater, right? Power goes down, disaster happens. So their RTO needs to be very small because it's a life and death situation that we are dealing with over there. I'm just giving an example, right? Compared to a restaurant where, power goes out, you can close the restaurant for maybe 3 or 4 hours. So their RTO is high. They're in a no rush per se. Then we have recovery point objective, which is the maximum period from which the data may be lost as a result of disaster. Now, what is recovery? And you will get question on RPO in terms of databases backup. That how, if it's a critical business, data is of critical importance, then you need to do a live data backup, because as the data is written, the data is backed up at the same time. So that where the recovery point objective is maybe very low to 0, because if disaster happens, your primary site goes down and you need to get back on the business, then you need to have the last data that you were on. So you cannot afford to lose any data when disaster happens. And usually, Wall Street and large financial institutions where data is critical, they have a very high write speed and read speed, and they have to have data available right there and then to make financial decisions. So their RPO is like pretty much 0. They have to have the latest data that they're working on. In other scenarios, if your data is lost, who cares? We'll recreate the data. It will take some time, it will take some effort, but their RPO may be not that important. So recovery service level, or RSL, it is the percentage of service that must be available following a disaster. And this is basically responsible of cloud service provider. And that's, again, you negotiate with the cloud service provider. Maybe you said, okay, disaster happens at the recovery point, I need 50% of my data to be there for me to continue my business. So you have to have that guarantee from your service provider that they implement such controls that if disaster happens, you will have your at least 50% of data should be available for you to continue your business. So that is recovery service level.
One thing, it's related to the data, or it's related to the service availability part? Because both are the completely different parts.
It's both. So service, yes, you're right, and data as well. Because you cannot do anything if your data is not there. Service available, data is not there, then you cannot do anything, right? So you need to have your data.
The data is covered by the recovery point objective?
Yes, it does.
Recovery point objective will cover up your data availability, and recovery service level is that, for example, the 50,000 request, I can handle it in normal time period, but in the recovery time period, the service provider or whatever, the IT department need to provide it that, okay, fine, in 1 hour time period, we can provide you the half lag of this, and you can put, let's say, 10,000 or 25,000 sessions per second. So that will give us that, that much service level will be restored in 1 hour time period.
You're absolutely correct, and hence my disclaimer when I was on this topic that I got confused on this terminology. So thank you for clearing up that, and you're absolutely correct. So RPO determines your data and RSL determines your service. Thank you.
One thing about RPO, so it's related to IT systems only that are running applications, and they do have the databases at the back end, right? What about the infrastructure nodes like routers, switches, firewalls, right? Is this RPO concept applicable to the infrastructure nodes as well? Because
I think that applies to RSL, because those needs to be available to process your data. So infrastructure related to RLL, because services are tied to that infrastructure, virtual machine storage and all that. And then RPO, is that correct, Zahid?
Sorry, I think the network or infrastructure side of the things will cover up in the RTO part. That how much time you will restore that things.
Yeah.
So
RTO deals with time, I think, and service level deals with the availability.
Yes.
Okay.
So with telecom infrastructure, usually we do have at other sites the elements are up and running, right? So what do we need? What we are trying to find from RTO is that how much time it will take to shift the service at the other side, right? At the time of disaster, will we try to recover the nodes at the primary site, or will we be finding the RTO?
Disaster site.
It should be clear. We shouldn't be like recovering the sites, trying to recover the nodes at the site of disaster. We should be finding the RTO for moving the services to the other side.
Exactly,
right?
And that's where the hot site, cold site comes in.
Yes, I was mentioning this thing there. It depends that which type of disaster recovery your organization the outside of
because if we go for the individual nodes, we are falling into the incident management, and that does not really serves you any purpose. Okay. Cool. Okay, so this is the RTO thing, and one thing that the disasters criteria should be very clearly mentioned, right?
Yes. In your disaster recovery plans, yes.
Yeah, so if you're not clear about your disaster criteria, then you cannot invoke your crisis management plan, then you cannot go for the business continuity plan and all those things. So, okay.
Yeah, so I think that's where, you have testing your BC and DR plans comes in, right? Because you need to make what you just mentioned, that you need to know what type of disasters you're talking about over here. And how do you know about that? You know about that by doing testing, right? And planning. And there are 5 types of DR testing. You do read-throughs, you do walkthroughs, you can do simulations, you can do parallel tests, and you can do full interruption tests. And you will get questions on full interruption tests and why you do it. So that's where all, you refine your processes over the course of time. You just cannot develop these plan one at a time. It will take time to develop and refine.
Yes, and it's very complicated, because then if you're talking about disaster, EHS and admin and human resource and everyone comes into play, right?
Yes.
So they're doing these sorts of interruption drills. It's very complicated process, and just doing the DR drills is different than performing these complete interruption tests, because then you're trying to close the service as well, just to test.
Yep.
Yeah.
So
you're right. That's the reason in the real world, most of the time of disaster, the things will not work, because we don't do the full interruption testing and when the good times will finish.
All right, so I think that's all what we have for today. This is the last slide.
Yeah.
The question sample. One guy asked it, so we said at the end of the course, you will show it.
There is a book by, where is this book? So there is a book from Cybex, And that book also has just question answers on each and every chapter. So it's pretty good. I practice on that to learn. And I'll try to share that book with you if I can find it.
Thank you.
Okay.
Yeah.
So this is the one that I was talking about.
Okay.
It's called Certified Cloud Security Official Practice Tests. So this is a book which has just questions of each and every domain, and you can practice it. And at the end, we have answers for you to also, an explanation of each and every answer. So this is a good, and I've practiced just this book for my exam. And it's an excellent source. I've actually written an article as well on my LinkedIn on how I passed it. And I shared some resources over there. So you can use that article to.
Is it possible you can share your link?
In the chat or in the video description? I think so Sajid Bhai can add it in the video description.
Yes, I am sending it right now in your chat.
Sajid Bhai, can you please post it with the video itself? So if somebody want to see it, they can go it in future as well. Like if somebody cannot copy it right now, they can use it as a reference in future also.
Sure, inshallah.
All right. I've just shared the link in the chat section. So if you guys want to.
Thank you, Ryan.
Okay. All right. Any other questions before we close the session?
It's too long, that's why I will not ask.
Okay. All right. Guys. So we'll talk in the next section then. All right.
Thanks a lot.
All right.
Thanks
Bye.
for your time, boss.
Thanks, Ryan.
Thank you very much. It was really amazing. Thank you.
All right. Thank you very much.